In this video, we'll show you how to run a brushless DC motor without a Hall sensor on a standard brushless DC controller that has a Hall sensor. Let's get started. I just salvaged this motor from a brushless lawnmower, and this is the main motor that you install the cutting blade on here. It does not have a Hall sensor. The only thing it has is a three-phase power wire, which is green, yellow, and blue, and that's it. As a comparison, this is a brushless DC motor from a hoverboard, and almost always all of these motors come with a Hall sensor. This is a three-phase power cable. This is the Hall sensor cable. The point of the Hall sensor cable is to allow the controller to recognize the position of the Hall sensor so that it will spin the motor more efficiently. But if you have a motor without a Hall sensor, most of the time you still can use a standard controller to run it. It's time to try out the brushless motor. I've got everything connected here. I've got 48-volt battery from my two Cobalt 24-volt power tool batteries. I've got a 48-volt brushless DC controller and my throttle control. Everything is ready to go. Here we go. Let's turn it on. Three amps exactly. See if we can run it real slow. There we go. As you can see, this motor is completely controllable with this controller, even though this controller requires a Hall sensor, and this motor does not have a Hall sensor. You can see this Hall sensor cable is disconnected, and I can still control this motor just fine. It runs quiet and it runs pretty smooth, and you can see the no load current is low enough. Around 3 amps is low enough. When you bench test this motor, and when it's not under load and the current is 8, 9, 10 amps, that means something wrong. Either your connection is wrong or it's not compatible with the motor. So I only connect the three-phase power wire from the motor to the controller, and there's no Hall sensor connected, and it still works just fine. There's also a couple of learning wires from the controller which allow the controller to learn about the position of the Hall sensor on the motor in order to turn the motor more efficiently. But in this case, it doesn't have a Hall sensor. So what happens when I connect the learn wires together? Let's find out. Alright, so it will spin the motor, try to learn the position of the Hall sensor. As you can see, before I plug this in, the motor turned counterclockwise, but now it's turning clockwise. So this learning wire also allows you to reverse the rotation of the motor. So now if I unplug this wire, right, it's turning clockwise, and before it was turning counterclockwise. Let's see what happens. There we go. Works just fine. So now the motor is running clockwise. If you want to reverse that, if you want it to run counterclockwise, you have to turn off the system. Okay, for first you gotta turn off the system. to remove power from the system first. Right, and then turn it back on. Right, it still runs clockwise. And now you plug in the learning wire. Let it do its thing. Once that's done, now the motor is running counterclockwise. Check this out. There we go. Now we can unplug this. And now it should still run counterclockwise. And you can see the current when it's not under load, it's very low. It's only about 1.5 amps. So there you have it. You can basically use this setup to run this motor on an electric bike, go-kart or scooter. Basically you can use this setup for anything that requires a motor. The possibility is endless. And that's all I have for now, folks. Thanks for watching. See you next time.